Okay, so with the robot that we're using, we're going to want to go ahead and change our counts per motor revolution to 1220, which is about what the Andy Mark motors that we're using is. And then we're just going to go ahead and change this gear reduction to 1 to 1 because that's what ours is. And then we're going to change this wheel diameter inches to 3. So now we've measured and we know that we want to drive off of the balance board 32 inches. So we'll change 32 inches right and left. Then we're just going to leave this the same. So then we can make changes to better reflect what we really want to do to get it lined up with that crypto box.
So after making a few changes to our distances and the code, we have our next iteration of our autonomous program we worked on together. 3, 2, 1. So in this example, we need to turn a little more and drive forward a little less, but you get the gist of it. This is how you can tweak your autonomous program, by making those changes until you have it working perfectly. I would highly suggest that you use a gyro for the turns, because the turns can get tricky based on traction of the field, but if you don't have a gyro, this is the only way you can go, really, and have an accurate autonomous program. So next up, we're going to work on a color sensor to show you how to get that added to your program and get you off and running. So right now we've got 10 points in our autonomous program. Let's see what we can do with the joules.
All right, so here we are, and we are now going to go over how to program the color sensor to knock off the joule when we read it. So first thing we're going to want to do is open up your auto drive by encoder and then go into the robot controller, Java external samples, and then find the Modern Robotics color sensor. That's what we're using. So we're actually just going to use this as just a reference. So what I always do when I am programming is I open up these codes side by side and then put in what I need from the color sensor's code into my code. So we're just going to find what we need. So right here we have color sensor. Well, we're getting the hardware device. So we're going to put that in there because we obviously need that. So we're going to do color sensor space, and we're just going to call it color sensor, the same as in the example. Now, from trial and error, we don't use any of these values or anything like this. So I'm just going to go ahead and skip all of that. And then we'll come down here to this where we're getting in the hardware map, and then we're using our configuration on the phone, and we'll call that sensor underscore color. So we'll find a spot in here. I'm just going to put it right here under robot.init. We're going to do color sensor equals hardware map dot get dot get string. We're going to do color sensor dot class comma string of sensor underscore color. And this is really nice because you can just look over here and just put the same thing in. So the next code we're going to look at is this color sensor dot enabled LED. So this turns on the LED light that is on the color sensor. So if you want it on or off, you can either do a true or a false. We're going to do true because it really helps to get the color of the joule. So this will turn on that light. So the next thing we're going to do, we can close out of that, is we're going to do another public void. So this one is the encoder drive. We're going to do a public void and call it joule. We're going to call it joule. And then we need to put in the parameters that we need. So anything that we want to enter in, we're just going to go ahead and do a double of timeout s. So that's the timeout in seconds. So the next thing we're going to do is this is where we put in an if statement of what we want it to do if the color sensor reads a certain color. So I do if color sensor dot blue is greater than 3. 3 is a pretty good value. You can do some tests yourself to see which value works for you, but we found that 3 is a good value for us. And this is if the color sensor is facing left towards the joule that's on the left. If you're on the balance board facing the joule and the color sensor is facing the left joule. So we'll say if the color sensor is reading blue, that means the jewel on the left is blue. And we're doing this code for as if we're on the red side, so we'll actually want to knock off that blue jewel. So we're going to go ahead and do an encoder drive. So the great thing about this is you can call this public void in your other public void. So that's great. So we just put in those values. We're going to do a turn. We want to turn right to knock off that jewel. So we're going to do left inches at, let's say, -2 and right inches at 2, and we'll give it a timeout of 2 seconds. And then we're going to want to do an encoder drive again to get us back to our original. So we'll do a left inches of 2, right inches of -2 to get us back, and a timeout of 2 seconds. So if the color sensor is reading red, that means that the jewel is red, and so the blue jewel is on the right side. So then in this case, we will want to do an else statement, and we want to do the exact opposite. Encoder drive, we'll do a turn. We want left inches to be the opposite of the first one, so we'll do 2 inches and then -2 inches, and the same timeout of 2 seconds. Then the encoder drive as well to get us back. Left inches at -2, right inches at +2, and a timeout of 2 seconds. So this reads that if the color sensor is blue, we're going to turn left and knock it off and then come back so we can execute the next part of our code. And then if it's reading red, then it's going to knock it off the other way. So either way, we will get to knock off the correct color if we are red. Now this would change based on what color you are. So that's not all. We notice that this is not highlighted, so it's not used in the code. So we're going to go up here, and these are our drives that we have talked about in our previous video. We'll put a link in the description for that, so you can check that out to come up to speed with this. But now we're just going to add in jewel, and we're going to do, let's say, a timeout of 4 seconds. So now we will hit the jewel. We will run in this jewel, run this jewel public void, and then we will do the encoder drives. Now, one thing I forgot to mention was that we have to put the arm down for our servo. So the very first thing we're going to want to do now, before we read the color sensor, is we're going to want to do robot.armServo.set position to 1.0. Now this is throwing an error because if you go and look at our hardware map, we don't have any arm servo. So we're going to have to put in a public servo. We're going to call that arm servo. We're going to equal that to null. After we have put that public servo, arm servo as null, we're going to come down here, and then we're going to say servo, or arm servo, I'm sorry, equals hwmap.get, and then we're going to say servo.class, and then we're going to call it the device name, and we're just going to call it arm servo. We'll have to put that in, put that in quotations because it's a string. And now we're good to go. We can go back here, and that was not capital. So now we're good to go. So now we can see what it's going to do is robot.armServo, it's going to set the position down, and then it's going to sense the color, and then it will perform these turns. And then what we're going to do is put in robot.armServo.setPosition. We want to bring it back up afterwards. So we're going to bring it to 0.0, and then we'll do the same thing after this one. So in this Joule code, we're going to set the servo position to 1, which brings it down. It may be switched depending on how your servo is placed. And then it's going to read the color sensor. If it's blue, it's going to knock the blue off and then bring it back up. And then if it's red, it's going to knock the blue off again on the other side, and then bring the servo back up, and then it will run this encoder drive code. So it will drive to the crypto box, and then it will stay there parked.
Okay, so here's our first attempt at using our color sensor. So as you can see, that happened way too fast. It didn't give it enough time to read the joule before it started moving. So we've got to make some programming changes. So stay tuned.
All right, so you just saw our autonomous running, and it was way too fast. So we didn't give it enough time to put the arm down and then to read the servo. So if you come down here to our code, we had the arm servo setting to the position of 1, but we didn't give it enough time to get to that position. So what we're going to do is cut that out of there, and then we're going to make just a new public void called arm down. And then we're going to give that another timeout so that we can give it enough time to actually execute. So we'll paste that right there. Whoops. So now we can give it enough time to put the arm down, and then we can run the joule code. So we'll scroll back up to this, and then before we run the joule code, we're going to run the arm down code, and we'll give that, say, 2 seconds to run. So it will put the arm down, it'll give it 2 seconds to run that, and then it will run this joule code where it reads the color sensor and then does the turn based on what it's reading. So we'll go ahead and load that code and try that and see if that works. All right, so after some trial and error, we have come up with a code that is working. And so I'm just going to go over that with you real quick, and then we will put a link in the description to our code so you can actually copy it and look at it yourself. So we ended up putting the arm down second for 2 seconds, and then the joule we have for 0.5 seconds to knock that off. And then I'll show you in the joule and the arm down code, we had to change it to a double hold time, and then we did elapsed hold time, hold timer equals new elapsed time, and then hold timer reset. So it creates a new variable for hold time and then resets it. And then we say, well, op mode is active and the hold timer.time is less than the hold time that we put up above. So it sets that new variable and then resets it, so we have a brand new time that we're working with, and then it goes to that time. So then we just copied that and then pasted it down here and did the same thing. So now it's working, and we'll show you that on the field.
Okay, so here's our autonomous video. It's run using encoders, using a color sensor and a servo that it'll move the color sensor in place of the joule so it can read the color, and then knock it off and then lift it back up as we drive forward. In 3, 2, 1. So there you have your first autonomous program. We hope to see you all out there with an autonomous program with this help and coding and information. As you can see, that's clearly a 40-point score in autonomous. The next part is to get your glyph mechanism set up so that you can score your first glyph using the Vuforia software. And hopefully our videos on that can help you. If you have questions, please feel free to reach out. We'll also post this sample code that you see here on our website at jagersrobotics.com. Please like and subscribe to our channel. We'll see you out there.